In this video, we will discuss complex and imaginary numbers. Taking the square root of a negative number introduces a new type of number. This new type of number is called an imaginary number. An imaginary number has a factor of the square root of -1, which is represented by the letter I. Imaginary numbers and real numbers combine to form the set of complex numbers. A complex number is a number that can be written in the form a plus bi, where a and b are real numbers. The square root of a negative number, say the square root of -16, can be simplified as the square root of -1 times 16, or 4i. Rewrite the imaginary numbers using the letter I for the square root of -1. The square root of -9 is equal to the square root of -1 times 9, which is 3 times the square root of -1, which is 3i. The square root of -25 is equal to the square root of -1 times 25, which is equal to 5 times the square root of -1, or 5i. The square root of -7 is equal to the square root of -1 times 7, which is equal to the square root of 7 times I, or I times the square root of 7. Because writing the square root of 7 times I can look like the square root of 7i, it is common practice to put I before the radical. Some powers of imaginary numbers are real numbers. I to the first equals I squared equals -1, I cubed equals -I, and I to the fourth equals 1. Since I to the fourth equals 1, I to the fifth equals I to the fourth times I, which is 1 times I, which is I. This pattern repeats forever. To simplify a power of I, if the exponent is greater than or equal to 4, divide the exponent by 4 and examine the remainder. The power of I simplifies as follows, based on the remainder in step 1. I to the 4x has a remainder of 0, so that's I to the 0, which is 1. I to the 4x plus 1 has a remainder of 1. I to the 1 equals I. I to the 4x plus 2 has a remainder of 2, and I squared equals -1. I to the 4x plus 3 has a remainder of 3, so that's I cubed equals -I. Simplify the powers of I. I to the 15th equals I to the 4 times 3 plus 3, which is I cubed, which is -I. I to the 20th equals I to the 4 times 5 plus 0, which is I to the 0, which is 1. I to the 33rd equals I to the 4 times 8 plus 1, which is I to the first, which equals I. And I to the 18th equals I to the 4 times 4 plus 2, which is I squared equals -1. A complex number has two parts, a real part and an imaginary part. In a plus bi, if a equals 0, then a plus bi is the same as 0 plus bi, or bi, which is an imaginary number. If b equals 0, then a plus bi is the same as a plus 0i, or a, which is a real number. Thus, real numbers and imaginary numbers are also complex numbers. Rewrite these numbers in the form a plus bi. 5 equals 5 plus 0i. The square root of 36 is equal to 6i, which is equal to 0 plus 6i. -3i squared equals -3 times -1, which is equal to 3, or 3 plus 0i. And 6 minus the square root of -5 equals 6 minus the square root of -1 times 5, which is equal to 6 minus I root 5. Complex numbers are combined by adding like parts. Real parts are added together and imaginary parts are added together. To add or subtract, combine complex numbers, add or subtract the real parts for the real part of the answer, and add or subtract imaginary parts for the imaginary part of the answer. Symbolically, a plus bi plus c plus di equals a plus c plus b plus d times I. Combine the complex numbers. 3 plus 5i plus 8 minus 2i equals 3 plus 8 plus 5 minus 2 times I, which is 11 plus 3i. Negative 3 plus I minus 7 minus 4I equals negative 3 minus 7 plus 1 minus negative 4 times I, or negative 10 plus 5I. Negative 2 plus 5 plus 6I equals negative 2 plus 5 plus 0 plus 6 times I, or 3 plus 6I. Multiplying complex numbers uses procedures similar to multiplying polynomials. Use the FOIL method to multiply complex numbers. Find the product 5 plus 3I times 6 minus 7I. 5 plus 3I times 6 minus 7I equals 5 times 6, that's the first parts, plus 5 times negative 7I, that's the outer parts, plus 3I times 6, that's the inner parts, plus 3I times negative 7I, which is the last parts. That's 30 minus 35I plus 18I minus 21I squared, which is 30 minus 17I minus 21 times negative 1, which is 30 minus 17I plus 21, which is 51 minus 17I. Two terms of the form a plus bi and a minus bi are called complex conjugates. The product of complex conjugates is a real number. A plus bi times a minus bi is a squared minus abi plus abi plus b squared minus b squared I squared, which equals a squared plus b squared. So 7 plus 3i times 7 minus 3i equals 49 minus 21i plus 21i minus 9i squared, which is 49 plus 9, which is 58. 5i minus the square root of 2 times 5i plus the square root of 2 equals 25i squared plus 5i times the square root of 2 minus 5i times the square root of 2 minus the square root of 2 squared, which is negative 25 minus 2, which is negative 27. Squaring a complex number uses the same procedures as squaring any binomial. 3 plus 5i quantity squared equals 3 squared plus 2 times 3 times 5i plus 5i quantity squared, which is 9 plus 30i minus 25 equals negative 16 plus 30i. 5 minus 2i quantity squared equals 5 squared plus 2 times 5 times negative 2i plus negative 2i quantity squared equals 25 minus 20i minus 4, which is equal to 21 minus 20i.